Hello everyone. Combinatorics problems from Tournament of Towns is an epitome of problem we try to inspire for our problem creation in SuMON. And here is an example of it. Today, we are going to solve a problem from Tournament of Towns 2020 Q3. This is from junior section of that exam. It is a combinatorics problem. In this, we are given with two people, Alice and Bob. Now they are playing the following game. Alice will be giving a number to Bob and Bob will be writing it on the board. And this number should be an integer. Now Bob is not going to directly write that number. Bob has two options. One is that he can directly write that number, and second option is that he is going to take the sum of this number with all the previous numbers that have been already written. And he was going to write that sum. Since there are two options, Bob can choose any one of them and write the resulting number on the board. Now in each step, Bob is writing the numbers that he reaches. The question asks for two parts. Can it be possible for Alice to design the numbers in such a way that there are at least 100 5s written on the board? And the second question, at least 100 10s are written on the board. Now we are going to figure out a strategy for someone, and you may also think, you may pause the video here and think for some time. Let's get started. So here is the question. As we could see, Alice gives the numbers to Bob and Bob has two choices, either to directly write that number or compute the sum of it with the previously written numbers and write the resulting number on the board. Now in each turn, Bob is going to write some number. So how do we make sure that Alice can devise a strategy to have at least 5 numbers? What if we think in the other direction? Let's say Bob comes up with a strategy to tackle Alice's suggestions and write out the numbers in such a way that not 100 or more 5s get repeated. So in that perception, if you think about the number 5, it is odd. So this is one deduction that you can make. And assume that you have a sequence already. And let's say T is the sum of numbers of that sequence. Now the next number has two possibilities. If Alice suggests the number n, then there are two choices for the next number, either n or n plus t. Now we have to make sure that n equals 5, then n plus t is not equal to 5. So that Bob is now not out of options, is not stranded. He will have the option to write n plus t. Now if n plus t is equal to 5, then n should not be 5. So that Bob again will not be left out of any options. So both directly implies that t is not equal to 0. Both of them is equivalent to saying that t is not 0. As you could see, if I substitute 5, you get t not equal to 0 when you cancel the 5 in both sides. Alright, how will I ensure that t is not 0? Let's take it for granted. For now, let's prove it by induction that if t is not 0 in some kth step, then I can make sure that in the next step, I'm not going to reach 5 either, or no, I'm not going to get a total sum of 0. How will I ensure that? Let's take a closer look. Assume that t is not equal to 0. Then let's take two options. Suppose if Alice suggests the number n, and if suppose it happens that t plus n equals 5, then we write the number n directly. Now notice that if I write the number n, I'm assuming myself as Bob now because I'm going to write the next entry. So the new sum will now be n plus t instead of t. Notice that n plus t is non-zero because n plus t is 5. So we are safe. Alright, what if n equals 5? If n equals 5, we now write n plus t. And notice that the sum will now not be 5 because the sum is actually n plus 2t. And since n is equal to 5, we have 2t plus 5, which is an odd number and clearly it's non-zero. So by this strategy, we reach the sum being not 0. And of course, n plus t is not equal to 5 because we ensured that t is not equal to 0. And similarly for the previous case, the entry is not 5 and the total sum is non-zero. Thus we can construct things like this. But what if both of them are not equal to 5? Let's assume the case in which t plus n is not equal to 5 and n is not equal to 5. In this case, you are just going to write n plus t because this is not equal to 5 and the total sum would be 2t plus n, which is going to be odd and it's not going to be 0. So we thus ensure that the new entry is not 5 and the total sum is non-zero. Thus we can proceed like this. This would be the strategy for Bob to not get many 5s. But he cannot avoid 0 5s because now we are asked for 10. So first observe that 10 is an even number. Let's try to prove that there exists a strategy for Alice to have Bob write 10 as many number of times as Alice needs. So let's take a closer look. Suppose in the first move, Alice suggests 10, then Bob will have to write 10. And now, Alice wants to make the sum of numbers either 0 or minus 5. Why 0 is quite important? Because if the sum is gonna be 0, if the sum of certain number is gonna be 0, then if Alice claims 10, then Bob has to write 10. Because 10 plus 0 is 10. So Bob will write 10. Or the new number is 10. So Bob should write 10 in either way. We were able to successfully avoid it in part A. But it might not be possible here. And we are going to give a strategy for the same. Earlier, we had the argument that 5 is an odd number. So it might be not possible for 2t plus n to be equal to 0 when n is 5. So here, that might not be the case. Suppose if the starting number is 10, then Alice will claim for minus 15. So if n is minus 15, then Bob has to write minus 5 or minus 15. So let's take two tracks. Minus 5 and minus 15. Minus 5 is because 10 plus minus 15 is minus 5. So that's why. Now if it's minus 5, then let me just write minus 15 here. If the number is minus 5, then so Alice will claim minus 10. So that means Bob will have two choices. Either to write minus 10 or 10 minus 5 minus 10 would be minus 5. So minus 5. So consider this case. 10 minus 5 and minus 5. The sum of numbers is 10. Minus 5 which is 0. Thus, Alice will of course claim the number 10 and Bob is now forced to write 10 because 10 plus 0 is 10, and if you consider the standalone number, it is also 10. So in either way, Alice is going to win this thing. And if this is the way, 10 minus 5 and minus 10, we know that the sum is minus 5, and let's claim for 10. So Alice is going to claim 10 and Bob is going to write 10 minus 5 plus 10 and minus 10. So the total sum would be just 5. So number written on the board will be 5 because he will try to avoid 10. Now in the very next move, Alice can claim 10 again, and notice that the sum of these numbers is 0 because 10 and minus 10 plus 5 and minus 5. So thus, Bob is now forced to write 10. Let's come to this way of minus 15. If it's minus 15, the total sum is minus 5. So we incorporate the strategy that we did for minus 5. That is, let's claim 10. Now Bob will try to evade writing the number 10. So he will write 10 minus 15 plus 10, which is plus 5. Now notice that the sum of all numbers is 0. So again Alice will claim for 10. So 0 plus 10 is going to be 10, or the new number is 10. Bob is now forced to write 10. So in all these three cases, possible cases, Alice is going to reach 10. Now if Alice just repeats this process again and again, Alice can get as many 10s as required. So 100 10s is achievable in this case. So the primary difference is that the number 5 was odd and there was a strategy to avoid the sum 0. But here, we can't avoid the sum 0 because number 10 is even. So try to generalize this result and add your ideas in the comments. We will try to discuss more problems from this exam, and you may also try it out online. All the exam papers are available from the past years. See you all in the next video. Thank you. Bye.